Section 7-4, Percents and Interest. This is the last section of the chapter. In the entire chapter, we've learned about how to talk about decimals. And one of the reasons why we want to talk about decimals is because percents are all over the place, and interest is incredibly useful for us to understand. So that's what we're going to talk about in this section. First, let's talk about what percent is. The word literally comes from a Latin phrase per centum, which means per 100. So we're talking about fractions with a denominator of 100. So how many parts out of 100? And we can translate between the fraction notation of a percent with some number in the numerator, always 100 in the denominator. We can turn that into a percent notation by just taking the numerator, whatever that number is, and slapping a percent sign after it. So if we're talking about a fraction like 3/4, maybe you say, well, hold on, 3/4 does not have 100 in the denominator, but you also remember that the fundamental law of fractions says we can multiply the number, any number we want, to top and bottom. In this case, let's pick 25 because 4 times 25 is 100. Then our fraction, which was 3/4, now looks like 75 over 100. When it's written in this form with a denominator of 100, all we do is take the numerator and write the numerator down, followed by a percent sign. So the fraction is gone. If, however, we were starting with a percent, so notice that example we just did was a fraction converted into a percent. If we were to go from a percent to a fraction or decimal, it's a slightly different process. Now, our brains are really good at making associations between things. So maybe you see that the problem we just did with 3/4 was equal to 75%. A really common mistake would say 3/4, that's related to 75. So if 3/4 was equal to 75%, maybe 3/4% is equal to 75 over 100, but that's not true. We have to be really careful not to make those kind of associations. They're incorrect, but they're common, unfortunately. So if we were to start with 3/4 of a percent, the first thing we would do is convert into a fraction. So we'll take the number in front of the percent symbol and we'll put it in the numerator. And of course the denominator is 100 because that's what percent means. Then from here, we'll say, hey, fractions inside of fractions are a little bit too much. So we'll take that 3/4 and write it in the decimal version, 0.75. We did not make any changes to the denominator. We just took our fraction and wrote it as a decimal. Then from here, we say, okay, technically, this is a percent notation. We have a denominator of 100. But remember, we're moving away from the percent and heading towards a fraction or a decimal. And having a decimal in the numerator, that's too much. We don't like to have fractions inside of fractions. We don't like to have decimals inside of fractions. So what we're going to do is multiply by powers of 10 to move that decimal. Notice that in 0.75, we would need to move the decimal twice to turn that into a whole number. So we need to multiply by 100 and on top and bottom. Multiplying the top by 100 gives us 75. Multiplying the bottom by 100 gives us 10,000. We could leave that as a fraction, 75 over 10,000. We could even simplify that. Both of those numbers are divisible by 5. Or we could write it as a decimal. We know that 75 over 10,000 means that we need to have 4 digits after the decimal, 1 digit for every 0. And the last digit in the decimal needs to be this 5, and then we work backwards. We have 7. We have 2 empty spaces, which we will use 0 placeholders for. So notice that we do have the 7 and the 5 in our answer. However, we've got a couple extra zeros here. So 3/4 of a percent is equal to 0.0075. Let's do a couple of examples of converting between percents and decimals and fractions. This first examples will start off with decimals or fractions, and we're going to convert to a percent. So our end goal is writing each number as a percent. For part A, we have 0.03, which is 3/100ths, or 3 over 100. This one's totally ready to go. Copy our numerator, slap on a percent sign. Anytime you have a denominator of 100, that fraction can easily be translated into a percent sign. Our next one is a little tricky because it's a repeating decimal. Now, if you are savvy enough to remember that 0.3 repeating is the fraction 1/3, then that's awesome, because from here you could try and multiply up to get a repeating pattern. Another way to do this, though, is to write this as 3 repeating over 10. 3 repeating would look like 3, 3, 3, 3, 3, 3, 3, but remember that's 3 as a whole number, so it'd be like 3.3 repeating. That's probably the better way to write it. Because 0.3 repeating has endless 3's that follow it, we can always string along more 3's here. Now we don't have a denominator of 100, so we multiply by 10 on top and bottom. That would become 33.3 repeating as our numerator, 100 on bottom. That would become 33.3 repeating percent. Now, if you remembered that 0.3 repeating is equivalent to 1/3, you could have used this to grow our fraction into a percent. Or you could even have done this the same exact way that we did, and for your final answer, say, oh, 33.3 repeating, that's the same thing as 33 and 1/3, where you don't have to write that repeating symbol. Next, we have 1.2. That would look like 1 2/10, or 22/10. Multiply top and bottom by 10 to get 220 over 100. That would be 220%. So again, once you get a denominator of 100, the numerator is just copied down in front of the percent symbol. Sometimes we start with a really small decimal, and we still want to turn that into a percent. In order to do this, we're going to start the same way that we have before. We're going to write our number as a fraction. Here we have 1, 2, 3, 4, 5 digits after the decimal, so our denominator will have 5 zeros. From here, I need to shrink my denominator rather than grow it. I have 3 zeros too many, which means if I divide by 1,000, I'll take care of those, and I would need to do the same thing on the top by the fundamental law of fractions. Our denominator would come out to be 100. Our numerator, 42 divided by 1,000, we could think of that as 42.0. Dividing by 1,000 is going to move the decimal to the left 3 times. That would become 0.042. And then we copy that into our percent, so 0.042%. That's equivalent to that decimal. Now maybe you're starting to recognize a pattern between the number we're starting with and the number that we're ending with in the percent. When you're starting with a decimal, moving to a percent, you're basically moving the decimal to the right 2 times. So whatever number you're working with, just move the decimal right 2 places. For example, the number 1 has a decimal immediately following it, and we could fill in some zeros so that it doesn't feel silly to have a decimal. To turn it into a percent, we just move the decimal twice to the right. 1 is equal to 100%. 3/5, we can turn that into a fraction over 100 by multiplying 20 top and bottom. We get 60 over 100. This turns into 60%. 2/3. Well, if I turned 2/3 into a decimal, that would look like 0.6 repeating. We know that 0.6 repeating is the same thing as 0.666 forever. So if I moved the decimal twice to the right, that would look like 66.6 repeating percent. Now notice that I'm putting an equal sign here, but I'm very careful to, on the left side of that equal sign, have the exact value, that's 6 repeating. And then on the right-hand side, I have the percent symbol here. That's what's making that equation true. We have one more down here, 2 1/7. The last fraction we have here is a mixed number, 2 1/7. Now 7 in itself cannot be written as 100 in the denominator, so what we're going to do is first convert that into an improper fraction. So that would be 15 over 7. And then I'm going to multiply this as if it were the numerator. So I'm going to multiply 15 over 7 by 100 and the denominator that I'm pretending to have, 1, by 100 as well. That way we have 1500 over 7 as our numerator and 100 as our denominator. Now technically this would be fine to write 1500 over 7%, or we could write that as a mixed number to say 214 2/7%. Now let's reverse this process. We saw a few examples of how to take a decimal number and to change it into a percent, but now let's look at some percents that we'd like to change into decimals. If we're starting off with 5%, the first thing that we should do is rewrite that as a fraction, 5 over 100. As soon as we turn it back into a fraction, the percent symbol is gone. Don't make the mistake of writing 5 over 100 and keeping the percent symbol. It no longer belongs here. From here, we can translate this into a decimal. We know that if there's 2 zeros in the denominator, then there should be 2 digits after the decimal. We'll copy in our numerator, starting from the very last place value, and putting in zeros for placeholders if we need them. If we were at 6.3%, same process. Let's write that first as a fraction over 100. And then notice that to translate this into a decimal, we need to get rid of the decimal in our numerator. So we'll multiply top and bottom by 10. We only need to move the decimal 1 place value. So we have 63 over 1,000. We have 3 digits after the decimal because we have 3 zeros in our denominator. So we would have 3 digits here, and we'll copy in our numerator in reverse. So 3, 6 with a 0 placeholder. 100%, turning that into a fraction, would be 100 over 100. We know any number divided by itself is equal to 1, so 1 is equal to 100%. That's a fact that we should keep in our mind all the time. 1 is equal to 100%. Next, let's look at 250%. That would be 200, oops, forgot my 5. 250 over 100. Now in this case, I know 100 fits into 200 twice, so I could turn this into a mixed number, 2 and 50 over 100. And I could simplify that fraction. Mixed numbers should always have simplified fraction parts. So that would be 2 and 1/2. Now before we finish these examples, I want to see if we're noticing a pattern in these examples the same way we did when we were converting decimals to percent. Notice that from 5% to 0.05, you simply moved the decimal twice to the left. Same with 6.3, we just moved the decimal twice to the left to get 0.063. From 100, we moved the decimal twice to the left. So this is a pattern we're recognizing, and it's going to become very useful in these last 2 examples. 2/3 of a percent. no matter how you try to rewrite this as a fraction over 100, you're going to have a decimal or a fraction in your numerator. I could write this as 2/3 over 100. And then from here, if I tried to convert this into a decimal, maybe I recognize 2/3 as 0.6 repeating over 100. But I have a decimal here that I can't get to go away. If I multiply by 10 over 10, that would turn into 6.6 repeating in the numerator over 1,000. I still have that decimal there. So what we can do instead is start off by taking the fraction and writing it as its decimal equivalent. So 2/3 is 0.6 repeating. We know that 0.6 repeating is 6 never ending. And if we're converting from a decimal into a fraction, sorry, from a percent into a decimal, percent to decimal, I need to move the decimal 2 places to the left. So that would look like 0.006 repeating. And if I had 33 1/3, I could rewrite that as the decimal version, which is 33.3 repeating. I know that that would look like 33 followed by an endless string of 3s. If I move my decimal twice to the left, I can turn that into a percent, which looks like 0.3 repeating. I said turn it into a percent again, and that's not what I meant. Decimal. This is a decimal. This is the percent. Sorry.